So I'm going to show two of the examples. I'm going to do two in this class and two in the next class and record them. Because last class it took too long and there wasn't as much time for the quiz as I wanted. But hopefully this one will be a little better. This is example one. So we need to go through our list of things. Okay, the first thing was to find the y-intercept. Again, how do you find the y-intercept? You substitute x equals 0. Right? So you got to say g, in this case of 0, is 3 over 0 minus 2. That's negative 3 halves. So the y-intercept is about here, negative 1 1/2. Let's see, the zeros of the function. Set the numerator equal to 0. Solve for x. Is there any x in the numerator? Do you see any x in the numerator? There's no zeros. There's no way to make that equal 0. It's a constant. So we have no zeros, which means it doesn't cross the x-axis. How about any vertical asymptotes? That would be the zeros of the denominator. Yeah, I mean, look at that right there. What's the 0? 2, right? So the vertical asymptote is x equals 2. So let me put that on the graph. Got that, got that. X equals 2. And the horizontal asymptote, which rule is going to apply here? The denominator has a higher degree than the numerator, so it is y equals 0, right? So we should have another asymptote here. Okay. Still on blue. So the horizontal asymptote, y equals 0. So then the next step is just plot some points. But we really don't have any, we only have one point on the graph as it is. That's the y-intercept. So it's not going to be enough to say, oh, let's just do 1 point beyond the vertical asymptote or 1 point beyond to the left. I mean, it wouldn't really give us much of a shape. So let's pick a few more points from that. How about we pick like this? Remember, you get to pick. Because they're x values, you get to pick. And the only value of x you cannot put in is 2. Everything else you could do. So how about if we put in, I would anticipate it's going to look like this. We know that the graph will approach those two dashed lines, right? So let's plot a point, maybe positive 1. That might show us what's going on there. And let's plot a point maybe over here. How about 1, 2, negative 3? Okay, and then on this side, there's nothing. So let's do 3 points. And let's do one that's a little closer to the vertical asymptote. How about 2 1/2? And then we'll do, how about 4 and 6? I mean, I'm just picking them up. You can make up at different points. The purpose is just to flesh out the shape of the graph. And I am going to use the calculator at that point. I was doing it in my head last class, and it really slowed things down. And I've already got the function in right there. So I'm going to go to the table of values. And because, like, I'm going to put in a fraction, right, not an integer value, I'm going to use the second table set. I'm going to have it set to ask, so I can just put in what I want, not just depend on what's in the table of values. So second, clear. Okay, how about 1? 1, negative 3, 2.5. No, positive. 4 and 6. What's that? You got something else?
No, it's the same thing. I just came up on it.
Okay. So now let's do that. Negative 3, negative 0.66. -3, -0.66, and 1.5, 0.75, 1.5, 0.75. So let's graph those points. What's that? How do you get to the graph? The table of values? Second graph. So 1, -3 is right there. -3, -0.6. So that would be about right there. 2.5, 6. So it's off the screen up on the top. 4, 1.5. And 6.75. So we kind of see this, right? Here it looks like this. Just draw a smooth line. We know that it approaches those red dashed lines. Draw a smooth line like so. Now, if we go back to the calculator and look, graph, let me zoom 6. Does that look pretty close? Or maybe drag it on this side. Does that look pretty close? Not bad, right? Now, does anybody have it on their 83 that you can see what the graph is? Did you do it? Did anybody bring it up on an 83 or an 83 plus and see that spiked line? Yeah, and you can see that it's connecting the two parts of the graph, and there's really nothing there. It's not a vertical asymptote. Calculator does not do that for you. That's just like a false line on the graph.